Okay, so this recording is to explain the answers for question 4 and question 5. So we will start with question 4. We need to find here best strand match. So what is that? You take two inputs, input and target strand, and we need to find the best similarity between the two DNA strands. So and we should print out the best similarity score. So we will print something and also return something. So there is two kind of output from this function. Okay, notice here what he said, that the DNA strand should be checked against the target strand, the length greater than or equal the target strand. So the input should be greater than or equal the target strand. So if it is not, then we have to return something to indicate that this condition is not satisfied. So we will see here in the error conditions. So if the parameters are valid, we return an integer representing the starting index of the substring in the input strand. So I will explain that later, but anyhow, we need to actually make sure that this target strand actually is represented in the input strand. Typically, when the target strand is actually shorter or even equal, so we either start from the 0 position, or we have to check which position when both the input and the target start to be matching. Okay, so that is maybe clear from here. So as you can see from here, this is an example. This is the input strand. This is the target strand, and the input in this case is bigger than the target strand. The target strand is only 4 characters. Here is almost like 13 characters. You see, we're always counting from 0 because this is programming. So yes, when we're counting from 0 until 12, it means that in total there are 13 characters. So this is again the target, and let us have a look at the condition here. So this is error handling and the conditions for the function to really operate. If the input strand is shorter, so if this is shorter than the target, so we should return -1, and we print the best similarity is 0.00. Okay, so we are not able to handle when the target is bigger than the input. So that's the first condition. Second is the function should make use of strand similarity. So this strand similarity actually we discussed it in question 3. So it means that the function that we produce in question 3, we will call it and we get an output from it, and then we will use it to print something. So this function prints something and return something. Okay, so what it will print out the strand similarity. So it will print a string calling best similarity score and this column, and then it will print the result from this strand similarity. We will have a look also at the function. So I know that I'm talking fast, but you can slow down and you can repeat if you would like to. So, okay. You may assume that the input best strand match will always be a valid DNA sequence. So it means that you don't really need to check the input if it is really valid or not. So the function that check if an input is valid is actually the one that is provided in the question 1. But we don't have to do that. So let us go and check what is the possible expected return values. So as we said, we print some values, which is the score, the best similarity score. So have a look here. So again, this input is bigger than the target, so it's acceptable. So have a look here. So we will look, this is an input, so we will try to see where we can match this T here. So possibly the best matching position is at position 2, so 0, 1, 2. So this is T is matching this T, and then this C is matching this C, and this A is matching this A. So the expected return value, which is actually the best position where these two, the input and the target, actually start to match. Okay, and then we will print also the best similarity score, which is 1. Why? Because we have three characters, and they 100% match the one in the input. So that's why for every one character we will say 1, it will get a value 1, and then C matching the C, so we get another, add another 1. If the A is matching the A, then we'll add another 1, and we divide it by 3, which is the total number. Same it is done here. As you can see, T is matching the T, so this is the target. G is matching the G, C is matching the C, and T is matching the T. So for every one is matching, we put 1 here, okay, and we divide by the total. So the total values in the target is 4. If all of the 4 is matching, so we put here 4. If only 3, so we put 3 and we divide it by 4. So now have a look. So again, here the input is bigger than the target, so it's acceptable. We will try to also see where we can start matching the A, so that we can best find the best similarity. So we see here, maybe we cannot put A here, okay, because we find that ACT maybe possibly have the highest possible matching. So A matching the A, C matching the C, the T is not matching, okay. So so it means that we have to put our target in the first position here, the index 1, okay, and then we will see that since we have 3 characters here, and 2 of them is matching, so it's 2 divided by 3. That's why you come up with this best similarity score. Again, the best similarity score is not a function that we are doing here. We have done it in question 3, so refer back to question 3. Now, if the input is actually smaller than the target, so we will return -1. We will not continue the function, and we will immediately print best similarity score 0.0, and this is mentioned in the condition above. Now, what about if the exactly matching? So if you count here 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So the input and the target both match in the length. So it means that we have no choice. We have to really start matching the T to the A. So this means that this position, we have to match both of them at position 0. And we find that the best similarity score is actually 0.5, because not all of them is matching. We will find that only if it is 0.5, it means that out of the 6, only half of them is matching. So I think this one, I think you can check it alone. Now let me go and have a look at the code, how this code actually is done. So okay. Okay, so let's have a look at question 4. So I will take that, I put it in the main and try to run. So I will remove the commenting, and then I will try to explain the function here. Yeah. So just as a notice, let me check if we explain this slicing here. No, we didn't explain the slicing. So this is the turn to explain the slicing here. Okay. So this is the helper function. It's called slice string. So this slice string is actually going to cut a string based on our input. So we will pass the string an input that we want to slice, and we will decide the start index and the length. So based on the start index, so imagine that you give it a string that is maybe that is containing maybe like 5 characters like that. So this could be passed as an input, the start index, you will tell it from where it will start to cut and what is the length. So this start index mark where you start to slice. So slicing means that you take part of the string and return it back. So the length, maybe you decide the length is 2 characters. So you start here and then you got 2 characters. So you return this t like that. Okay. So here we're checking for certain conditions to make sure that the function is actually have a valid inputs. Okay. So the length cannot be less than 0. Okay. And the start index cannot be less than 0. And the start index cannot be if it is bigger than the length. Okay, so we cannot start here. So this is all conditions that make this function fail. So if it fails, so I need to return an empty string. Okay, means that I'm not going to slice anything. So if actually it works, and if this condition is passed, if statement is okay, so it means that we didn't return. So we will execute that this kind of loop. So in this loop, we start from 0, and we make sure that we don't exceed the length here. Okay, and we also make sure that this start index plus I is less than the length. So we should not exceed the length in anyhow. We should be less than the length. What we're going to do here, that we keep adding character by character. So this loop will loop through all the characters in this input, as you can see. So we will start, okay, with I equals 0. So the start index here are going to be used for cutting. So we are starting here. So imagine that your start index equal maybe 2. So here 0, 1, and 2. So your start index is 2. So it means that here is 2. You start with I equals 0. So 2 plus 0. So you got the first character, which is t. So you are now having in result t. Okay. So you will execute that line and then loop again and try to increment the I. So the I now equal 1. And then we check the condition. Is it the length I is still less than the length? So imagine the length is equal to, so means that we need to have 2 characters. So now the I equal 1. And we also need to make sure that the start index, which is 2 plus 1, is less